Okay, see Lindelof videos. Implicit differentiation and then evaluate at a point. So we're given this equation, not a function, of course, right? We're given this equation that y squared is equal to x squared minus 49 over x squared plus 49. So we're going to look at this. We're going to take a look at this, and we're going to start to differentiate this thing out. First thing I'm going to do is I'm not even going to worry about this. I'm going to start to differentiate this. So if I was taking the AP exam or preparing this for my professor, I would say my intention is to take ddx of this whole thing. So that leads to this. That says that we're going to take ddx of y squared, and we're also going to take ddx of x squared minus 49. You don't have to use this notation, but I just want to declare my intention to you. I'm going to go ahead and take the derivative of this. So the derivative of y squared in terms of x is really weird. The first thing I'm going to do is I'm going to look at this way and say, okay, this is a chain rule problem, so I'm going to take the derivative of this outside piece, which is 2, whatever goes on the inside, to the first power, right? And then we put this piece back on the inside, so that's, right, this is me using the chain rule here, so this is CR for chain rule. I'm using the chain rule here. Then I have to multiply that, so it's the derivative of the outside times the derivative of the inside. And the first derivative of y is, well, frankly, it's the first derivative of y. So that's all I'm saying there. Some scholars will write, or sometimes you'll see on an AP exam, dy dx or y to the first y prime used interchangeably, and that actually makes a lot of sense. I'm going to go ahead and differentiate the right-hand side now. So this is obviously a quotient rule problem, isn't it? So I'm just going to set this up and say, look, f of x is equal to x squared minus 49. F prime at x, the derivative, f of x is the top part, right? So is x squared minus 49. The derivative of that is simply 2x, isn't it? G of x, which is the bottom portion, the denominator, is equal to x squared plus 49. And similarly, its derivative is also 2x. So I'm going to go ahead and set up my quotient rule here. So as I set up my quotient rule, we know that quotient rule is g of x, so we have x squared plus 49 times g prime at x, which is 2x, isn't it? Just 2x, minus, and I'm going to have to erase this to make some room for myself, times f of x, which is x squared minus 49, times g prime at x. Remember, g prime at x was also 2x, right? G prime at x was also 2x. Over, and remember, g of x is x squared plus 49. But if you remember the quotient rule, then we square that g of x value, don't we? So that's what I'm going to get here. When I open this whole thing up, and when I distribute this whole thing through, I end up with, if I distribute this through, I end up with 2x cubed plus, what is it, 96x? 98x, sorry, 98x, right? Minus 2x cubed minus 98x all over this thing at the bottom, x squared plus 49 squared. Look, if I distribute this negative sign through, so now I'm looking at this negative sign right here. If I distribute this negative sign through and simplify, look, also have to remember that I still have this 2y times y prime. All right? So I look at this, I'm like, okay, this is working out okay. I distribute this through. This turns into, let me just show you here. I distribute the negative sign. This positive becomes a negative, and this negative becomes a positive, right? So far, so good. So now, I'm going to just keep simplifying. 2x cubed minus 2x cubed is 0x cubed. 98x plus 98x is 196x, right? So equals 196x all over x squared plus 49 squared. So far, so good. I'm not going to do anything with this. So I always have people ask me, should I evaluate, should I expand this, should I open this up? The answer to that question is, why would you? And if there's a good reason that you would, then go ahead and do it. But if you can't come up with a great reason why you would do it, then frankly, why are you doing it? So then look, we have 2y times y prime. Our goal is to get y prime by itself. and then to evaluate. So we're trying to get this by itself. So I'm going to multiply by 1 over 2y. So that's going to give me that y prime is equal to 196x over, remember we're multiplying by 1 over that, so that gives us that 2y back at the bottom, right? X squared plus 49 squared, right? Can simplify this and this. I'm not even going to bother with this crap, but I could simplify that. The reason I'm not going to bother with it is because I have to evaluate, and I can already see something happening here. Remember, we're supposed to evaluate at 7, 0. So if I evaluate this at 7, 0, all I have to do is this. I'm like, you know what? Here's where the y value is going to go. And the y value that I'm evaluating at is 0. Well, if I turn this to 0, I don't give a crap what the rest of this thing does. It's going to go to undefined. So in this case, the derivative is undefined at the point 7, 0. So undefined is my answer, and there's my work. All right, look, you guys, I hope this was really helpful. If you have any comments, please leave them. If you haven't already subscribed, please do, and I appreciate everything. Peace.